हरिः कर्ता।
Now let's look into the discrete variables, which is also a type of data in numeric data types, in numeric data. So as we have discussed, numeric data that are expressed on a numeric scale. So now it consists of continuous as well as discrete. So now we'll be understanding discrete variables. So what is discrete variable? So a discrete data that can take on only integer values such as counts. This is very important, the counts. So synonyms, we use it for this discrete data are integer or count. And we also have discrete data, we can call it as discrete data can usually be counted in a finite matter. In a finite matter, if you take it in numbers, it's a rounded off 1, 2, 3, 4, how many bottles you want, how many liters of water. Just we say, of course we can have 1.5, 1.6, and but still, so we'll take 1 liter, 2 liter, 1 kg, 2 kg, but that's okay. But that's not the main example of this. So the main one is uh, how many kids you want, or how many bags you want to take, how many uh, jobs you did. So how many jobs you did, so how many companies you have worked with, how many vehicles you have, how many bikes you have. So basically it's widely used for the count, a count of something, how many siblings you have, how many sisters you have, how many friends you have. So these are all like a lot of these are some of the examples for discrete variables. So let's take one example. So take the number of children that you want to have. Let's take this example because I used to uh, discuss this thing with my girlfriend a lot of times. So even if you do not know how many, you are absolutely sure that the value will be an integer, not floating point number. So a number like it could be 1 or 2 or 3. So my girlfriend's choice was 1, if not 2, if I force it's 3, that's the maximum. But for me 4 or 5 is fine, sometimes 8. So that's what that's how. So you're not sure how many you want, but how many you don't know, but you're absolutely sure that the value will be an integer. It could be 1, 2, 4, 5, 8. It's not 1.5, it's not 2.5, it's not 3.5, or it's not 1.125. Okay, this is an integer. So this is called, this kind of representation of any feature is known as discrete data. This is known as a discrete data. So another instance is grades on the SAT exam. So you may get 1000, 1560, 1570, 2400. So what is important for a variable to be defined as discrete is that you can imagine each member of the data set. So we know that SAT scores range from 600 to 2400. Moreover, 10 points separate all possible scores that can be obtained. So we can imagine and go through all possible values in our head. So therefore, the numerical variable is discrete. So that's how, if these conditions are satisfied, then the data can be represented as a discrete data. So we will look into more examples here. So for more examples of discrete data, just to make sure, here are, just to make sure and understand better about the discrete and continuous data together. So grades at universities are discrete. It could be a B, a C, a D, or E, F, or it could be the percentage even between 0 to 100. What you, at the end of the day, what you get is discrete. Then the number of objects in general, the number of objects in general, no matter if bottles, glasses, tables, or cars, they can only take integer values. And the money can be considered both. It could be discrete, or it can also be considered as as a continuous variables, depends upon the application. Okay, so but physical money like banknotes, if you take banknotes and coins, they are definitely discrete. But if you just take, if you do a random calculations using money, that's continuous variable. There will consider that data as continuous data. Whereas if you take the banknotes, currency notes, or coins, these are definitely discrete. You can't pay 1.243 rupees. You can pay 1 rupees or 10 rupees or 2 rupees or 3 rupees or certain amount, because now even we are not using of rupiah. So we are using only rupee or 2 rupee or 5 rupee. There is no 1.5 rupee at this moment, that was removed. Before it was there. So we are not using that of rupee anymore. So that's how, when you use a coin, we can use 1 rupee coin or 2 rupees coin or 5 rupees coin. That's it. It's absolutely discrete. So you can only pay that amount. So that's because the difference between two sums of money uh, can be 1 rupee at most. That's what. That's how it is designed at this moment. Before it was 1 paisa, and before that it's called ana something ana. That's the least one. And before that we used to have pavala, ardha, ana, pavala, and half rupee. That's a 50 paisa, and then 1 rupee. But now those were all removed and scrapped. So now what we have is the least one is 1 rupee. So that's the reason, because the difference between two sums of money can be 1 rupee at most. So that is the reason we say this is discrete. If you look into the same example in dollars, money, again money can money. So there, the difference between two sums of money can be 1 cent at most. So you can, so there also we can call it as a dollar that you pay using banknotes and coins are discrete.